Hi everyone, it's Mr. H here, and this video is all about going from a velocity time graph and using the slopes of the different segments to generate an acceleration time graph. So to go from a velocity time graph to an acceleration time graph, we have to take the slope of each straight line segment on the velocity time graph. And so if you remember, slope is equal to rise over run. And what we're going to do is we're going to calculate that for each straight line segment on this graph. So if we take this first straight line segment that starts up at 6 and ends down here at 2, we can see that the rise over the run is going to be equal to -4, because it's going from 6 down to 2, so it's -4. The units there are meters per second to the north. And then the run is going to be going from 0 out to 2. And so that's 2 seconds. And so -4 divided by 2 is -2. And then meters per second is meters per second squared. And that's why it is an acceleration. So -2 meters per second squared north. Let's continue finding the other slopes and then we'll graph it below. Here we can clearly see that the slope of this next segment is 0 meters per second squared. For the same reasons, the units are meters per second squared as they will be for all of these, but the rise is 0. So it's clearly going to be 0 meters per second squared. Now the next segment, we can see that the rise is going from 2 up to 4. And so we're going to go, that's a difference of 2 meters per second to the north. And then the run is going from 6 out to 10. And so the run is going to be 4 seconds. And so that means the slope of this next segment will be 0.5 meters per second squared to the north. Now the next segment, for the same reasons as it was for that second segment, is 0 meters per second squared. And then now we have this negative slope again. And so we're starting at a value of 4. We're ending at a value of 1. And so the rise is going to be -3. So -3 meters per second to the north. And then the run is going to be from 12 to 14 seconds. And so that's 2 seconds, which gives me a slope of -1.5 meters per second or meters per second squared. And so now what we need to do is just translate that to the graph below. And so what we want to do now is we want to recognize that we're going from -2 meters per second squared. That's our smallest slope. And our largest slope is 0.5 meters per second squared. And so we want to then make a new x-axis a little bit higher up so that we can clearly see all these values. So you can see I've moved that x-axis up, or that time axis up. I'm going to make that 0. I'm going to go up by 0.5 and down by 0.5 as well. And so this will be -1, -1.5, and -2. And so this is meters per second squared. It's an acceleration, and that's in the northwards direction. And so what we're going to do here is we're going to start with the first 2 seconds from 0 to 2. So all the way from 0 to 2. And that was a slope of -2. So that's going to be a horizontal line straight across there because the slope was constant all the way from 0 to 2 seconds. Then from 2 to 6 seconds, we have a slope of 0. So that's going to be a horizontal line right there across at slope 0. And now we go to the next segment, which is 6 to 10 seconds. And we can see that the slope was 0.5. So we're going to draw a horizontal line at 0.5 on the acceleration time graph. And now we have 0 again from 10 to 12 seconds. And then finally from 12 to 14 seconds is -1.5. So we're going to go down here and draw a horizontal line right across there like so. And now all we have to do is we have to just join those with a vertical line between the segments so that that jumps from one piece to the next piece of it. And there is your acceleration time graph. The last thing we can really do is just add the times to this, but everything lines up exactly with what is above it. And so there's our times in seconds, and your acceleration time graph is now complete. If this video was helpful, please like and subscribe. You can check out the velocity time to the position time graph on the right and more physics videos on the left. Thanks.